Assalamu alaikum students. Myself Zain Javed Mughal, your science teacher of grade 8. So in the previous class, we have dealt with the explanation of acids. Now the next topic that we are going to deal with today is base or alkalis. Robert Boyle, as I have foretold you that Robert Boyle has coined the term acid for first time. Same the Robert Boyle also termed the base or alkali term first time. Bases have properties contemporary to acids. It means that bases are in contrast with the acids. That is, the properties of bases are totally changed or in contrast with the acids. So, how they are changed with respect to the bases? There are some characteristics that are related to the bases. That is number one, bitter taste. As when we are dealing or explanation about the acid, we have deal that acids have a sour taste. So now the bases have a bitter taste. Number two, slippery or soapy touch. The bases have a slippery touch or soapy touch. Therefore, there is a reason that the bases are already used in the soap making industries also. Number three, it changes the red litmus to the blue, while the acids change the blue litmus to the red. Red color is indicating the presence of hydronium ion, and the blue color is indicating the presence of hydroxide ions or hydroxyl As we have already done an activity in the classroom about the litmus paper, that the litmus paper, when dipped in the basic solution, it turns from red to blue. So this is also a characteristics of a basic solution or base. Then now number four, lose strength when mixed with water. When the bases are mixed with the water or dissolved in the water, the bond between the basic compound breaks down and produces hydroxyl ion that results in the losing the strength when mixed with the other water. Now we have another type, that is chemically a base is a substance which release hydroxide ion with dissolve in water. It means that the definition of base is basically that the base is a substance which releases hydroxide ion. And while the acids are those substances that release hydronium ion, that is H plus. Okay, but in the case of base, we have another type of ion, that is hydroxide ion, or we also say them the hydroxyl ion, that is OH minus. So when dissolved in water, the bases produce which ions? Hydroxide ion, that is OH minus. For example, when the sodium hydroxide in its aqueous solution dissociates as NaOH, Na plus, and OH minus. It means that whenever you dissolve a sodium hydroxide in a solution or to make a solution in a water, the sodium hydroxide breaks down into two from this point, Na and OH. Na has a positive charge and the hydroxide has a negative charge. So Na positive and OH minus dissociates in the water. Therefore, the bases loses strength when dissolved in water, because whenever the base is added to the water molecules trap these basic molecules and break their bonds in between them and separate them from each other, ultimately losing the strength of the base. And in this case, the base is eligible or can produce hydroxide ions in the solution. Some examples of bases are, we have several type of different bases. The most common that some main examples are sodium hydroxide, that is Na stands for sodium, symbol of sodium, and hydroxide is represented as OH. So NaOH is the symbol or formula for the sodium hydroxide. Then we have a potassium hydroxide. Potassium is symbolized as a capital K, and then hydroxide is symbolized as a KOH. So therefore, the formula for the potassium hydroxide is KOH. Then we have a calcium hydroxide, calcium Ca and hydroxide OH. There is a two valency of the calcium, that is calcium is able to donate a two electron, therefore it has a positive charge. So if we have a plus 2, to balance this we must also have a minus 2. Therefore the one OH ion has a minus 1 charge. So for the minus 2 charge I have to take OH2, that is two hydroxide ions can ultimately lead to the charge minus 2. Therefore, CaOH2, that is calcium hydroxide. And same for magnesium. Magnesium also donates two electron to the other atoms. Therefore, it contains a double positive charge. So for the double positive charge, there is necessity for the double negative charge. So one hydroxide ions contains one single charge that is -1. So the two hydroxide ions can contain a double -2 charge. Therefore, the +2 and -2 can alternately balance them each other. So due to the abundance of mobile hydroxide ions, bases conduct electricity in their aqueous solution. Remember that every that solution that contains the free electrons or ions. So that type of solutions can easily conduct the electricity when they are in aqueous medium. So remember that whenever the bases are dissolved in the water, we know that the bases ultimately gives us hydroxide ion, that is OH minus ions. And these OH minus ions are the responsible for the producing or conducting the electricity in the aqueous solution of bases. So whenever you dissolve the sodium hydroxide in the water, it dissociates into the OH ions, and the OH ions is responsible for the electricity generation in that NaOH solution. So in short, that whenever you are going to dissolve the base in the liquid or the water, so the presence of OH ions can make it able to conduct the electricity in the laboratory in the chemical reactions. And remember the main point and highlight them in your book, students. That is, bases that dissolved in the water are called alkalis. All the bases are not alkalis. Remember that words. All the bases are not alkalis, but all the alkalis are bases. तमाम अल्कली जो है वो बेसिस हैं, मगर जो बेसिस हैं सारी वो अल्कलीज नहीं है. Because only those bases that are able to dissolve in water, that are soluble in water, are called alkalis, while the insoluble bases that are not readily or easily soluble in the water are not termed as alkalis. They are simple called bases. But those bases, I'm repeating again and again, but those bases that are dissolved in the water, that can be or that may be dissolved in the water, are called alkalis. Okay. So now we have same like the acids, we have further classification of bases on the basis of two categories on the basis of their strength, means dissociation power. So the first is a strong base. A strong base, what is a strong base, students? Bases which dissociate completely in water. Means those bases which dissociate. Dissociate means, as I have foretold you in the classroom also, that dissociate means decompose, dissociate, to break down something. So whenever the sodium hydroxide is added into the water, then we have seen the equation that the sodium hydroxide get dissociates into the Na plus NOH minus. Means that whenever the sodium hydroxide is dissolved in the water, it dissociates into the Na plus and OH minus. So those bases which dissociate or ionize completely in water and produce high concentration of hydroxyl ions are known as strong bases. It means that whenever you are going to dissolve any base in the water, and if all the molecules of that base dissociates completely and produces OH ions into the water, these types of bases is called as strong bases. For example, sodium hydroxide, potassium hydroxide. These two bases are the examples of the strong bases that we are dealing in our syllabus today. Then we have a weak base, the weak bases which dissociate or partially in the water. Remember that there is one word difference between the strong and the weak base, that is partially and completely. If the base is completely ionizing or dissociating into the water, then this base is called as a strong base. And if when you are going to dissolve the base in the water and the base is partially dissociates or partially ionized into the water and produces a low concentration of OH ions, then these bases are known as weak bases. For example, ammonium hydroxide, that is NH4 for ammonium, OH for hydroxide. The formula for ammonium hydroxide is NH4OH. Okay, students, I hope that these terminologies and these classifications and terms have been clear to you. Now we are going to deal with some of the chemical properties of bases. So bases when react with different compounds, they also show some characteristic properties, likewise as an acids. Whenever the acids react with different metals or different compounds, then it produces the particular components and particular products. Likewise, we have also the bases over here that react with the acids and the ammonium salts and produces the particular product, that is the identification of the characteristic or maybe the chemical property of that base. Now, the number one reaction is a reaction with acids. Remember that whenever the alkalis and the insoluble bases, these are the two different words. As we have discussed above that, the alkalis are only those bases that when dissolved in water and easily solubilized, those type of bases are called as alkalis. While the other bases that not readily or not easily soluble in the water, these are only called as bases or insoluble bases. But alkalis are those bases that can be completely or easily dissolved in the water. So whenever the alkalis, either it is a soluble water soluble base or insoluble water base, so whenever these two types of bases react with the acids, it always forms salts and water. Likewise, all alkalis and bases react with acids to produce water molecules. Only remember that whenever the acids react with the base, either it is the alkali base or the insoluble base, always whenever the acid reacts with the base, it always produces the salt and water as a product. As you can see in the equation, that acid gives H plus ion and bases gives OH minus ions. Therefore, it can produce water. Now we have an acid H2SO4, that is sulfuric acid, and we are going to react with the base, that is copper oxide. Copper oxide is not readily or easily soluble in water, therefore it is a base, not an alkali. So whenever the copper oxide is reacted with the sulfuric acid, now see the reaction over here. The sulfuric acid breaks down, how it breaks down and gives it ions to the different upcoming compound. This H2 and SO4 dissociates and H plus separates out and SO4 minus separates out. Same in case of here, copper oxide, the plus 2 charge of copper, the copper separated out from the oxygen and oxygen remains single. Then both the molecules' opposite charges attract each other, like the positive charge of an acid attracted the negative charge of the base, and the positive charge of base attracted to the negative charge of an acid. You can see clearly here that SO4 is the negative part of the acid. The negative part is basically called as anion. Any compound, any substance that has a negative charge, it can be termed as an ion. Remember that we are going to use this word again and again in the reactions now upcoming in the upcoming lectures. Then the positive charge compound or any charge or any substance that has a positive charge on it, that type of compound is called as cation. Okay, class, this is cation. So, in short terms, whenever you see a negative charge on any element or any formula or any compound, it means that this is called as an ion. And whenever you see the positive charge on any substance or any atom or element, it means that this is a cation. So, the positive charge containing a component of an acid called as cation. So, the cation of acid reacts with the anion of the base. That means that the positive of the cation acid reacts with the negative of the base. Same, the negative or the anion of the acid reacts with the positive cation of base. Then you can see clearly here the plus 2 charge attracted to the minus 2 charge, and these both compounds bond make a bond together and form a CuSO4, that is copper sulfate, called as salt. Then the positive charge of an acid, that is cation of an acid, reacts with the anion of the acid, H2O, and forms a water molecule. That means the salt and water as a product is formed. So this reaction justifies that whenever you are going to react the acid with any base or alkali, it will ultimately give you a product that is salt and water. Now again, we have a second type of reaction. The copper oxide is basically the base. Now we are going to react that same sulfuric acid with the alkali. That is a type of base that is easily soluble in the water. So now you can see over here that the sulfuric acid again is now going to react with the calcium hydroxide, that is soluble in base, that is alkali. So the calcium hydroxide is again breaks down and the sulfuric acid again dissociate into this ion. Acids give hydrogen ion that contains a positive charge, and the bases give hydroxide ions that contains a negative charge. If in any formula one part is of negative charge and the other part must be and should be of the positive charge. Same in case of acid, if the hydrogen contains a positive charge, then sulfate contains a negative charge. So again, now the two different compounds attracted the opposite charges respectively, like that H plus of the acid reacts with the OH of the base, because H plus contains a positive charge and the base has a negative charge containing on the OH. So the H plus and the OH is going to combine together and forms a H2O, that is two water molecules. Now the calcium containing a plus 2 charge on it, and the sulfate of the acid SO4 contains a minus 2 charge. So for the rule of attraction, the calcium having a positive charge is always going to react with the negative part of the acid. So whenever the calcium plus 2 attracted to calcium sulfate, it will combines and forms a CaSO4 calcium sulfate salt. So this is another justification that whenever you are going to react the acids with the alkalis or the bases, it will always produce your salt and water. Now we have a second type of reaction, that is reaction with the ammonium salts. What are ammonium salts? The salts that contains ammonia or ammonium structure, ammonium compound in their structure, that is called as ammonium salts. Basically the ammonium is symbolized or formalized as NH4. So strong alkalis react with ammonium salts to give off ammonia gas. Remember that this is for objective. Maybe it can be asked you in the exam that whenever the strong alkalis react with the ammonium salts, it gives off dash gas. So remember that it always gives us ammonia gas whenever the strong alkalis react with the ammonium salts. So the gas that is evolving during the chemical reaction is the ammonia gas. That is a very pungent in the smell, and that make you feel dizziness, and it can produce headache if you stand in the presence of this gas for a prolonged time. So ammonia gas is always characterized by its pungent smell. So in the reaction, you can see the reaction clearly over here. The NaOH, the strong base, when the strong alkali is going to react with the ammonium salt, that is ammonium salt, ammonium chloride. So this again breaks down that NaOH, Na and Cl, NH4Cl. This positive attract to the negative and forms NaCl. One H from ammonia goes to the HO, that is 2H2O, and forms water, and NH3. If there are four hydrogen atoms before combining with the OH, then if the one atom is shared with the OH, then the remaining are three atoms. So the NH3 will be left, and this NH3 is basically the ammonia gas that evolves during the chemical reaction when the ammonium salts are reacted with the strong alkalis. So we have two type of chemical properties of bases. That is, whenever the bases are going to react with the um, react with the alkalis or acids, it always produce the salt and water. And whenever the bases or strong alkalis react with the ammonium salts, it always produce ammonia that is identified or characterized as a pungent smell. So this is the basically also a chemical test that can be used to confirm the presence of an alkali or the ammonium salt. So whenever you are in the laboratory and you want to detect that this compound either contains an alkali or the ammonium salt, so you can run this reaction, and if the ammonium evolves from this reaction, this is the indication, or this is the identification that that type of compound or that type of reactants must contain any of alkali or any ammonium salt. Then we have another topic, that is uses of base. But before going to jump to this topic, we can solve this brainstorming that can reinforce our the previous lectures. So brainstorming said that overeating can make your stomach produce too much acid. You know that by the Allah Almighty, we have already an HCl in our stomach, that is an acid, hydrochloric acid, that is used to dissolve our food that we intake on the daily basis. Then the first question is that, okay, whenever you are have overeaten and your stomach produce an excess of acid to neutralize or to break down that food component. So, which type of substance is contained in the product that can be taken to reduce the discomfort and pain caused by the extra acid? So, the first question is, whenever you are feeling the acidity or you have an increased concentration or increased amount of acid in your stomach, so what you have to use to relieve or reduce the discomfort and pain that is caused by the production of the extra acid? So, any one of you guesses? All right. I know you can give answers correctly. So, the good and correct answer is antacids or antacids. The medications that are used to neutralize, that are used to uh, relieve the discomfort or reduce the discomfort and pain caused by the production of extra acid in our stomach, the antacids are used, or antacids can also be said to them. The second question is, what is the name of the reaction that provides you with relief from the effect of extra acid? So, yes, any one of you students guesses? What is this? This is basically neutralization reaction. What reaction is it? It is the neutralization reaction. Okay, students, now you have to remember this, that the reaction, the chemical reaction that provides you relief from the effects of acid is called as neutralization reaction. So whenever the acids, the excess of acids reacts with the base, then the salt and the water is formed, and this type of reaction in which the acid and base react to each other and form salt and water, this type of reaction is called as neutralization reaction. Now come back to the topic, that is uses of base. So uses of base, we like acids, bases also have a very useful and some of the important uses of bases are here that we are going to deal. And this is basically the last topic of our today's lecture. So the first base, that is sodium hydroxide and the potassium hydroxide. So sodium hydroxide and potassium hydroxide are two different bases that are used in industries and in other many sectors. So what are their uses? First of all, you must know the common names of these bases. The sodium hydroxide is commonly known as caustic soda, and the potassium hydroxide is commonly known as caustic potash. Remember that the caustic soda is the common name of sodium hydroxide. So whenever if I ask you in the exam or in any time in the classroom that what is caustic soda, so you must be aware of that. The caustic soda is basically the sodium hydroxide, NaOH. And if I ask you in the classroom that what is the caustic potash, so you must be aware of that. Caustic potash is basically the potassium hydroxide having a formula of KOH respectively. Now, what are their uses? First of all, as I have foretold you in the characteristics of the base, that the bases have a soapy and slippery touch. Therefore, the soapy touch is due to this property. These are used in the manufacturing of soaps. It means that these two bases are the key components or used in the production of soap, then paper, paints, and medicines also. Okay, in refining of petroleum, whenever the crude oil, whenever we dig the soil or underground, then the crude oil or the black oil extracted out, a black liquidy and thick material is extracted out, that is called as petroleum, and from the refining of that petroleum these bases can be used. Number third is a cleaning agent to remove grease from the machine parts. It means that these bases are also used to remove grease from the machine parts, and grease is some type of lubricant material that is so slippery and greasy. So it uses on the machines to reduce the friction. So whenever you have to remove this grease from the parts of machine, you are going to use these bases, that is sodium hydroxide, commonly known as caustic soda, and potassium hydroxide, commonly known as caustic potash. Now we have a second base, that is calcium hydroxide. So calcium hydroxide is also generally commonly known as slaked lime. You must be aware of these common names because these names can be asked in the exam and in the CTs or MTs. So you must be aware of these. Common names. The calcium hydroxide is generally known as slaked lime. It is used in the preparation of whitewash, mortar, plaster of Paris. So it is the first used in the whitewash whenever you're going to do a whitewash in your homes or whatever thing. So the calcium hydroxide is used. Mortar, plaster of Paris is also composed of calcium hydroxide salt. Okay. So in manufacturing of cement and bleaching powder, for the manufacturing of cement, the gypsum is the key component of the cement, and the gypsum contains the calcium hydroxide and calcium salt. Bleaching powder is also a key component containing a calcium hydroxide. For testing of carbon dioxide gas, yes, remember that carbon dioxide is the gas that turns the lime water, that turns the slake lime water to a milky, means that if the slake lime water is transparent or not a milky solution, so whenever the slake lime solution comes in contact with the calcium hydroxide or carbon dioxide gas, this gas turns that liquid material to a milky solution. It turns or change its colors to a milky texture. So it is used for the testing of carbon dioxide. So whenever you are confirming that either the carbon dioxide is produced in the reaction or not produced, so you are able to do this reaction that you contact the slake lime and carbon dioxide gas, and if the slake lime solution turns milky, it is the indication that there must be a carbon dioxide present. Number last is the for neutralizing acidic soil. So whenever the acid rains affects the soil nature or soil components of our environment, then the calcium hydroxide can also be used to neutralize the acidic soil and make it feasible for the growth of our crops in the field. Then we have a last salt, that is ammonium hydroxide, that is be formalized as ammonium is NH4 and hydroxide is OH. So ammonium hydroxide is has a formula that is NH4OH, and this ammonium hydroxide is used in the manufacturing of fertilizers. What are fertilizers? Fertilizers are the chemical compounds or the substances that are used by the farmers for their crops for their proper nutritious growth. Then we have a rayon, plastic, paints, dyes, and cleanser. These all type of compounds contains ammonium hydroxide in their ingredients. So there is an interesting information about the water that you have familiar that the water has a both ions, that is hydronium ions, hydrogen ions, and hydroxide ions. So it acts as a base in some reactions and as an acid in other reactions because it can produce H plus and OH minus both ions. So whenever in any type of reaction it is going to produce the hydrogen ions, it means that the water in this reaction is acting as an acid, and whenever in any of the reaction the water is producing the OH minus ion, that is hydroxide ions, it means that the water in this reaction is acting as a base. And in the DUNOX sector, you also must be aware of bases as well as of acid. Likewise, of acid, bases are as dangerous as alkalis. Okay, we have told in the classroom that the alkalis are more corrosive to your skin and more corrosive to a human body. Then bases are also more dangerous to the alkalis. For example, the aqueous solution of sodium hydroxide can blind you in a matter of minutes if not cleansed proper thoroughly. It means that whenever you have prepared the sodium hydroxide solution in the lab and this solution comes in contact with your eyes, it can ultimately lead you to blind if you are not rinsed it properly or cleaned it properly. So this is all about today's lecture. Inshallah, in the next class, we are going to deal with the new topic, that is salt. We over here just completed our acids topic and the bases, in which we have completely deal with the definitions of bases, chemical properties, and uses of different bases in our daily life. So I hope so you have gone through this lecture very well, and if you have any further question, you may ask me in my next lecture or in any classroom. Thank you so much for your kindness and for your time. Thank you so much.